Good morning, students. Welcome back to chemistry class. So today we are going to study about heavy water. Heavy water and chemical properties of heavy water and then uses of heavy water. That's all today we are going to study. Okay, listen carefully, take notes. First upon heavy water. Heavy water means, isotopic forms of hydrogen. There are three isotopic forms of hydrogen having. What are the three isotopic form? Hydrogen H11 protium, D12 deuterium, T13 tritium. Okay, these are the three isotopic forms of water. When these three isotopic forms of water, hydrogen, three isotopic forms of hydrogen, that is protium, deuterium and tritium. Okay, these three isotopic forms of hydrogen when combines with the oxide, the oxides of these isotopic forms of hydrogen. For example, H2O means oxide of protium, oxide of proton, oxide of protium. Protium, deuterium, tritium, three isotopic forms of hydrogen. Here H2O means it is the oxide of protium. Okay, so H2O we called as the ordinary water. Ordinary normal water. We are using the drinking purpose. That water we called as the ordinary water. That is H2O. Okay, and oxide of heavy hydrogen. Oxide of heavy hydrogen. That is the deuterium. Deuterium is the heavy hydrogen, one of the heavy hydrogen. So the oxide of heavy hydrogen, that is called the heavy water. There is D2O, oxide of heavy hydrogen. Okay, this is called a heavy water. Oxide of super heavy hydrogen. Super heavy hydrogen means tritium. Tritium is the one of the radioactive element. Super heavy hydrogen, tritium. Okay, the oxide of tritium, that is called the super heavy water. T2O we called as the super heavy water. These are the three isotopic forms of water. Okay, now we are going to study about the heavy water, that is the deuterium oxide. That is the oxide of heavy hydrogen. Oxide of heavy hydrogen. Okay, so the heavy water is the oxide of heavy hydrogen. It is very, present very small amount in the earth atmosphere. For example, 1 part of heavy water is present in 5,000 parts of ordinary water. If you are taking 5,000 parts of ordinary water, this 5,000 parts of ordinary water contains 1 part of heavy water, that is D2O. Okay, so 5,000 parts of H2O contains 1 part of D2O. D2O means heavy water, oxide of heavy hydrogen. Understood? How we can obtain the deuterium oxide, that is the heavy water? How will you prepare? The heavy water can we can prepare by the electrolysis of ordinary water. Okay, electrolysis of ordinary water, we can prepare the heavy water. Okay, electrolysis of ordinary water, we can prepare the heavy water. Understood? So ordinary water means H2O. It undergoes the electrolysis. It undergoes electrolysis with light alkali. Okay, the pure water, it does not conduct the electricity. We know pure water, H2O, the pure water does not conduct the electricity. So we are adding slightly alkaline. There is sodium hydroxide. Okay, so any alkaline solution mixed with the water, when continuous electrolysis, electrolysis process already we studied. Okay, continuously electrolysis of this ordinary water, we get the heavy water. Ordinary water, all the hydrogen gases evaporated, all the hydrogen gases evaporate. After that we get the deuterium water, that is the D2O. Okay, so electrolysis of D2O, it does not undergoes electrolysis. It cannot undergoes electrolysis, but ordinary water only undergoes electrolysis by adding slightly alkaline. Okay, understood? These are about the preparation of heavy water. And what are the physical properties of heavy water? What are the physical properties? The heavy water, that is D2O, we know that is the colorless, odorless and tasteless liquid. Okay, normally normal water, ordinary water, H2O also colorless, odorless and tasteless. Like that, D2O is the colorless, odorless and tasteless liquid. And it has the different physical properties of ordinary water and heavy water. Okay, different physical properties having when comparing the ordinary water and heavy water. In page number 107, you can refer the page number 107, the table 4.2. The table 4.2 having the properties. The properties of heavy water and ordinary water and super heavy water properties are there. Molecular weight, melting point, boiling point, temperature of maximum density, vapor pressure, viscosity, dielectric constant. All the properties are given in the table 4.2. Understood? These are about the heavy water. And then we are going to study about the chemical properties of heavy water. Chemical properties of heavy water. What are the chemical properties of heavy water? Okay, here when compounds containing the hydrogen, one of the compound containing the hydrogen, it is treated with the D2O. D2O means heavy water. The hydrogen undergoes an exchange for deuterium. Okay, when compounds containing the hydrogen, for example, one of the compound containing hydrogen, sodium hydroxide, one of the compound there is the sodium hydroxide. In this compound, hydrogen is having compound containing hydrogen. When we are treated with the D2O, heavy water, the hydrogen present in the compound, the hydrogen present in this compound can exchange for the deuterium. The hydrogen in compound can be exchanged for the deuterium. Okay, for example, sodium hydroxide, one of the compound, it contains hydrogen ion. When we are adding heavy water, that is D2O with the sodium hydroxide, the hydrogen present in the NaOH, it exchanged by the deuterium in heavy water. Okay, so what is the product we get? NaOD. Instead of hydrogen, one of the deuterium join here. Okay, the hydrogen replaced by the deuterium. Okay, understand? So remaining, what is the remaining product? Here one hydrogen having and here one oxygen and one deuterium having. Okay, so remaining we get HOD. This hydrogen and this oxygen and one deuterium. One deuterium in the deuterium water, it replaced by the hydrogen atom in the NaOH compound. Understand? Now we have to balance the equation here. Sodium, how much sodium atom having here? Only one. Here also only one sodium. Oxygen, how much oxygen atom having here? 1, 2. 2 oxygen atom here also 1, 2. 2 oxygen atom having. Hydrogen, how much hydrogen atom having here? Only one. Here also only one hydrogen. Deuterium, how much deuterium? 2 deuterium. Here 1 deuterium and here 1 deuterium. 2 deuteriums are having this. Okay, now balance the equation. This is the one of the chemical property. Okay, this is one of the example. Okay, for exchanging this deuterium atom. Another one example I am taking, when hydrochloric acid. hydrochloric acid, it contains the hydrogen. Okay, the hydrochloric acid, one of the acid, it contains the hydrogen ion, hydrogen. When we are treated with the deuterium water, that is heavy water with this hydrochloric acid, the hydrogen and the hydrochloric acid are replaced by the deuterium. Instead of this hydrogen, deuterium is present here. Okay, instead of this hydrogen, the hydrogen is replaced by the deuterium. The hydrogen is exchanged by the deuterium. Okay, so what is the product we get here? Instead of this hydrogen, one of the deuterium present in the heavy water takes place here. So we get DCl. DCl, deuterium chloride. And then what is the remaining product? Here one hydrogen, one oxygen and one deuterium. So we get HOD. Okay. And next another one example, one of the compound containing hydrogen, that compound we call as ammonium chloride. One of the another one example, ammonium chloride exchange reaction here. When ammonium chloride treated with the deuterium oxide, heavy water, the hydrogen present in the ammonia. How much hydrogen atom having here? Ammonium chloride, what is the formula? NH4Cl. NH4Cl, ammonium chloride. Here how much hydrogen atom having? Totally 4 hydrogen atom having. The 4 hydrogen atom are replaced by the deuterium. Okay, the 4 hydrogen atom replaced by the deuterium. So we get ND4Cl and the remaining 1 oxygen, and here 1 oxygen and how much hydrogen having here? 4 hydrogen atom. Okay, 4 hydrogen atom replaced by the deuterium. So we get here 4 hydrogen and oxygen and deuterium. Okay, so we have to balance the equation here. Ammonium, for instead of 4 hydrogen atom, 4 deuterium atom exchanged here. Okay, so we have to take here, and 4 hydrogen atom in the ammonium chloride, it form 4 HOD. Okay, so totally how much deuterium having? 4 plus 4, totally 8 deuterium atom having. So we have to make here 4 twos are 8 deuterium. Deuterium is balanced now. Nitrogen, only 1 nitrogen here also only 1 nitrogen. Hydrogen, how much total hydrogen having here? Totally 4 hydrogen, here also 4 hydrogen. Okay, understood? And chlorine, how much chlorine? Only 1, here also only 1. Oxygen, 4 oxygen, here also 4 oxygen. Okay, so these exchange reactions are useful. What are the uses of exchange reaction? Okay, these are about the exchange reaction. First reaction, sodium hydroxide, one of the hydrogen compound, when treated with the deuterium oxide, it exchange hydrogen present in the sodium hydroxide exchanged by the deuterium. So we get sodium deuteroxide. And another one compound containing hydrogen, that is hydrochloric acid, treated with the deuterium oxide, we get the deuterium chloride, DCl. Okay, hydrogen in HCl, it is completely replaced by the deuterium from in the deuterium oxide. Okay, and the remaining product HOD. Okay, and another one exchangeable reaction, NH4Cl, ammonium chloride, when you are treated with the deuterium oxide, heavy water, the hydrogen, 4 hydrogen atom present in the ammonium chloride replaced by the 4 deuterium atom. So ND4Cl, what is the name of this compound? Deuterated ammonium chloride. Deuterated ammonium chloride. Okay, and 4 HOD. Okay, these are the HOD means hydrogen deuterium monoxide. Hydrogen deuterium monoxide. Okay, so these are the exchange reactions. Okay, and then we are going to study about what are the uses of exchange reaction. What are the uses of exchange reaction? First use, these exchange reaction are useful to determine the number of ionic hydrogen. Number of ionic hydrogen present in a given compound. Okay, so how much number of ionic hydrogen having here? That all ionic hydrogen can be replaced by the deuterium atom. So by the exchange reactions of deuterium oxide, we can determine how much number of ionic hydrogen having in a compound. This is one of the use. Another one use, we can determine the basicity of acid. We can determine the basicity of acid by using the exchange reaction of deuterium oxide. Okay, so for example, we are taking one of the example, hypophosphorus acid. What is the formula for hypophosphorus acid? H3PO2. Hypophosphorus acid, H3PO2 plus deuterium oxide, D2O. H3PO2, that is called hypophosphorus acid. It is treated with the D2O to form. Okay, all other before we are studying three reactions, all the hydrogen atom in a compound completely exchanged by the deuterium oxide in the heavy water. But here only one hydrogen replaced by the deuterium in heavy water. Okay, only one hydrogen. H3PO2 means hypophosphorus acid. When we are treated with the deuterium oxide, that is the heavy water, the only one hydrogen, H3, how much hydrogen atom having here? 3 hydrogen atom totally. But here all the 3 hydrogen atom does not replaced. Okay, only one hydrogen atom only replaced by the deuterium from the heavy water. Okay, understand, sir? So here H2, what is the product we get? H2DPO2. Okay, H2, only one hydrogen replaced by the deuterium. Okay, H2D, okay, only one hydrogen replaced by the deuterium. So we here having deuterium H2DPO2. Understand? So remaining, what is the remaining product? One deuterium replaced by the one hydrogen. So this one hydrogen combines here. So we get HOD. Here only one deuterium having only one hydrogen replaced by the only one deuterium. So we get remaining product, one hydrogen, one deuterium and one oxygen, HOD. Okay, understood? So by this exchangeable reaction, it indicates this hypophosphorus acid. It is a monobasic acid. Understood? So by the exchange reactions, we can understand what is the use of exchange reaction. By the exchange reaction, we can understand the basicity of an acid. We can understand. Understood? This is the one of the example. And another one uses. Okay, and then also here also having uses having, it is also used to prepare some deuterium compounds. The deuterium heavy water, that is deuterium oxide, we can prepare some deuterium compounds. What are the deuterium compounds? We are going to study how the deuterium heavy water is used to prepare the deuterium compounds. Okay, for example, one of the example we are taking here, aluminium carbide. What is the formula for aluminium carbide? Al4C3. Okay, Al4C3. This is the aluminium carbide. What is the formula? Aluminium carbide, what is the formula? Al4C3. Okay, when it react with the deuterium oxide heavy water, D2O, we get aluminium deuteroxide. Okay, so when aluminium oxide, when treated with the aluminium carbide, when treated with the ordinary water, means H2O, we get the aluminium oxide, AlOH thrice, and 3 AlOH thrice and methane, CH4 we get. This is the reaction of aluminum carbide with ordinary water. But with heavy water, we get aluminum deuteroxide, AlOD thrice, AlOD thrice plus CD4. Okay, instead of this, if we are using ordinary water, we get the methane, CH4, we get the methane, that is the CH4. Okay, but here it is one of the heavy water. So when we are using heavy water here, we get the CD4. Okay, CD4. And then we have to balance the equation here. We have to balance the equation here. Here, how much aluminum having here? Totally 4 aluminum having. How much aluminum having? 4 aluminum. So we have to make here 4 because 4 aluminum having here. So we have to make here 4 aluminum. And the carbon, how much carbon atom having here? 3 carbon. So we have to make 3 here. How much carbon? 3 carbon. And how many deuterium having here? Only 2. But here how much deuterium having? 4 3s are 12. 4 3s are 12 and 3 4s are 12. So 12 plus 12, 24 deuterium having here. So we have to make here no deuterium, only here only having 2 deuterium. Okay, so we have to make here 12. Now 24 deuterium, 12 2s are 24. 24 deuterium is present here, and then we are going to balance the oxygen. How much oxygen atom having here? 12 oxygen. But here how much oxygen atom? 4 3s are 12. Oxygen also balanced here. So equation is balanced. And another one equation having, another one example having, that is the calcium carbide. Another one chemical compound, calcium carbide. Calcium carbide, when treated with the deuterium oxide, we get the calcium deuteroxide. Calcium deuteroxide. Okay, when calcium carbide it is treated with the ordinary water, we get the calcium hydroxide. But here we are using only deuterium oxide, so we get calcium deuteroxide. We get calcium deuteroxide. Okay, understood? Calcium deuteroxide, and we get another one byproduct, C2D2. Okay, if you are using ordinary water H2O, we are using here, means we get the calcium hydroxide and acetylene, C2H2 we get, that is acetylene. But we are using only heavy water here, so we get the calcium deuteroxide and C2D2. What is the name of this compound? Deuterioacetylene. Deuterioacetylene. C2 means acetylene, compound is acetylene, so deuterioacetylene. Deuterioacetylene. And another one example here, magnesium nitride. Magnesium nitride. What is the formula for magnesium nitride? Mg3N2. Mg3N2. Okay, Mg3N2. When we are treated with the heavy water D2O, we get magnesium deuteroxide. Magnesium deuteroxide, and then we get the ND3, deuterated ammonium. Deuterated ammonium we get. Okay, ND3. Deuterio ammonia we get. Okay, and now we have to balance the equation. This equation also we have to balance here. How much calcium here having? Only 1. Here also only 1 having. Carbon, how much carbon having? 2. Here also 2 carbon. Deuterium, how much deuterium having? Only 2. But here 2 plus 2, 4 deuterium having, so we have to make here 2 2s are 4. Now deuterium balance. Oxygen, how much oxygen? 2 oxygen. Here also 2 oxygen. Equation is balanced. This equation, magnesium, how much magnesium having? 3 magnesium, but here only 1, so we have to make here 3 magnesium. And nitrogen, how much nitrogen? 2 nitrogen, so we have to make here 2 nitrogen. Deuterium ammonia. Okay, and deuterium, how much deuterium having here? 2, but here 3 2s are 6. 3 2s are 6. 6 plus, here also 2 3s are 6. Okay, 6 plus 6, 12 deuterium having, but here only 2 deuterium, so we have to make 6 here. Now only equation is balanced. Okay, 6 2s are 12 deuterium. And oxygen, how much oxygen having? 6 oxygen. Here 3 2s are 6. Okay, 3 into 2, 6 oxygen having here. Equation is balanced. And another one equation also having calcium phosphide. Calcium phosphide. What is the formula? Ca3P2. Ca3P2. Okay, calcium phosphide. When we are treated with the heavy water, we get the calcium deuteroxide, and it remove the deuteriophosphine, PD3. Okay. If we are using ordinary water, means we get the calcium hydroxide and phosphine, pH3 we get. But here we are using only heavy water, so we get the PD3, deuteriophosphine. So we have to balance the equation here. How much calcium here having? 3 calcium. So we have to make here 3. Okay. Phosphine, how much phosphorus having? 2 phosphorus. Here only 1. So we have to make here 2. Okay. Deuterium, how much deuterium having? 3 2s are 6 and 2 3s are 6. Totally 12 deuterium having. So we have to make a 6. So 6 2s are 12. Oxygen, how much oxygen having here? 3 2s are 6 oxygen. Here also 6 oxygen. Okay. And now equation is balanced. This is the uses of deuterium by the exchange reaction. Okay, understood? And then we are going to study about uses of heavy water. This is the chemical properties. We completed up to the chemical properties of heavy water. Now we are going to study about the uses of heavy water. What is the uses of heavy water? There are 3 uses given. Very important book bag question also. This is the book bag question also. Uses of heavy water. Okay, the first use, the heavy water is widely used as moderator. What is the uses of heavy water? First use, the heavy water which is used as the moderator in nuclear reactor. Nuclear reactor means they are having the nuclear fission reaction, nuclear fusion reaction also having. Okay, so nuclear fission means decomposition takes place there, and it neutrons only reacted there. Okay, neutrons when bombarded with the neutrons to decompose the nucleus. Okay, neutrons only they are using. Okay, so moderator, what do you mean by moderator? Means the moderator, one of the moderator means one substance which used to slow down the reaction of neutron. Slow down the reaction of neutron. That is the uses of moderator. Moderator means one substance used to slow down the production of neutron. Okay, so in the nuclear reactor, the neutrons are highly high energetic. It produce the neutrons, and also produce nuclear fission reaction also takes place there. But we are using the deuterium oxide, that is heavy water, is used as the moderator in the nuclear reactor. It can lower the energies of first neutron. It can lower the energies of fast neutron. Okay, moderate. So, in what is the use of first use of heavy water? The heavy water is used as moderator to lower the energies of the fast neutron. To lower the energies of the fast neutron. Very, very important. This is the first use. And the second use, what is the second use? It is commonly used as a tracer. Okay, it is commonly used as a tracer to study the organic reaction mechanisms and mechanism of metabolic reaction. Okay, it is commonly used as the tracer. Tracer, what do you mean by tracer? Tracer means one of the substance can help and identify or observe. Okay, observe the process. Okay, observe the process. That is maybe organic reaction mechanism and maybe metabolic reaction. What do you mean metabolic reaction? The reaction takes place in the living things. The metabolism means it break down, the process of breaking the process of break down our food. Okay, food to energy. Okay, process of breaking the food to transfer the energy. Okay, the process of break down the food to energy. Okay, that is called the metabolism. Okay, so there in the mechanism of metabolism reaction, heavy water used as a tracer. Okay, tracer, how the reaction going on, and what is the which one is the how much the electrons, movement of the electrons and protons. Okay, that all absorbing the heavy water. Heavy water is to tracer to study the organic reaction mechanism and mechanism of metabolic reaction. Okay, so what is the second use of heavy water? Heavy water, it is commonly used as the tracer to study the organic reaction mechanism and mechanism of metabolic reaction. Organic reaction mechanism and mechanism of metabolic reaction. And another one uses also having, it is used as a coolant in nuclear reactor, as it absorbs the heat generated. Okay, in the nuclear reactor. Okay, in nuclear reactor, there large amount of heat is produced. Okay, large amount of heat is produced when fission reaction or fusion reaction. Large amount of heat is generated. But here heavy water, when we are using heavy water in the nuclear reactor, it acts as the coolant and it absorbs the heat generated. Okay, how much heat generated? Heavy water absorb that heat. Okay, so it is used as the coolant in the nuclear reactor. Understood? So what is the three uses of heavy water? First uses, heavy water, it is used as the moderator in the nuclear reactor. Second uses, it is commonly used as the tracer to study the organic reaction mechanism and the mechanism of metabolic reaction. And third use, it is also used as the coolant in the nuclear reactor. Okay, these are the three uses of heavy water. Very, very important. Okay, students, today our assignment, give the uses of heavy water. Give the uses of heavy water. Very, very important question. If you have in book, take your book now. Students, take page number 111. At the left hand side of the page, the last 4.6.2, uses of heavy water. Okay, there are three uses having. First one, heavy water is widely used as the moderator in nuclear reactor as it can lower the energies of the first neutron. Second use, it is commonly used as a tracer to study the organic reaction mechanisms and mechanism of metabolic reactions. And third use, it is also used as a coolant in nuclear reactor as it absorbs the heat generated. Okay, up to here you have to mark. Everyone should study and write the assignment and send me through my WhatsApp number. Okay, thank you students. Thank you.